a tree is 86 centimeters when it is planted. In the first year after it is planted, the tree grows 42 centimeters in height. However, here they said each year thereafter, the tree grows by 95%. You see, of the previous year. It says find the height of the tree 5 years after it is planted. So here, don't do too much in your head. Put it on paper first. So it starts at 86, right? And they said it grows 42 centimeters in height. So meaning it starts at 86. If you add 42 to that, what is it gonna be? 100 and what? 100 and
isn't 120?
128. I think. I hope.
128.
Yeah, it's gonna be 128. But then they said each year thereafter the tree grows by 95% of the previous year. So obviously our whole pattern is going to start from here. You see, this one is almost useless because the jump from here to there is not it growing by 95%. This is more than 95%. I mean, this is like less than 95%, sorry. Because here it's saying each year thereafter the tree grows in height by 95% of the growth of the, oh, wait, hold on. No, let me not confuse us. Let's just leave it. It says here the first, when it is planted, it is 86. I was about to even make a mistake here, but reading again helped. So it starts at 86, right? So they told us that the jump from the 86 to the 198, it's 42. And then from 128 going onwards, it grew by 95%. So if anything is growing, right, it says here, thereafter the tree grows in height by 95% of the growth of the previous one. So it means that it grew by 95% of 42. Do you see?
Oh, okay, because of the original. No.
Yes. Yeah. So these
Because
are the
of the
kinds of
original
questions.
growth.
Yes. So these are the kinds of questions where you may want to write out a few terms manually before you think of formulas and all that. So you see 95% of 42, what is that? What is 95% of 42?
39.9.
39.9. Okay, fine. Is that rounded off to 2 decimal places?
No, it's just round up the first decimal place.
Okay, what about to 2 decimal places?
To 2 decimal places, there's nothing. It's just 39.9.
Okay, fine. So you have to see the next one is the adding 39.9. So what is 128 plus 39.9?
167.9.
167.9. Fine. And then it grew by 95% of this. So what is 95% of 39.9?
$159,505.
It's equal to what?
159,505.
100 and wait, really? It can't be.
Oh,
It's supposed to be smaller.
sorry, not okay. My mistake. Okay. 37,905.
37,905.
Mm-hmm.
Okay, and then if you add that to the 60 or to the 167.9,
205,805.
205.
805.
Okay, fine. And then we have to do one more. They said here, this we also then need 95% of 37.905. What do we get there?
We get 36,01.
Okay, and then if you add that to this,
We get 241,81.
0.81.
Oh, okay. 475.
475.
No. It's 241,81475.
Like this. How is that possible?
Yes. What? Are you not adding the?
I'm saying this number here plus this number here.
Oh, I rounded it off. That's why. Okay, let me use the rounded off version. 241,815.
241.
815. So when writing these things, right, are we not supposed to round it up by 2 decimal places?
Well, yeah, that's the best way to do it, to round off to 2 decimal places. Because if you don't round it off to 2 decimal places, I mean, if it has decimals, you're better off maybe rounding it off to 2 decimal places. But then when you see how this question is, just writing out the height of these three, right? You can see do you see that it doesn't make like a nice looking formula type of thing, but fortunately this here is what can at least make sense. Starting at 42, it becomes 39.9, it becomes 37.905, it becomes, is this rounded off?
Yes, I did round it off.
Okay, fine, let's leave that one out. What about the previous one? Is this rounded off?
No.
Yeah, let's leave these three. Do you see that if you're working with just the way the trees are growing, it's easier to have a sequence, because this is telling you that one or the other, the first year it grew by 42, and then the second year it grew by 39.9, and then it keeps growing by 95%, 95%, 95%, so that you already know that if you're going to work out how much it has grown, if you're going to work out like question number 1, right, which is asking find the height of the tree 5 years after it is planted, all you have to do is you just need to, this number you got it, what is this number before without it being rounded off?
The number before.
Yeah,
Oh,
what's this number without, okay, hold on, you can just, let me just pause this. Sorry, I'm just getting this call. So the point I'm trying to make with this kind of question is that it will be easier for you to keep track of the values of how much it's increasing by, as opposed to you keeping track of the actual height of the tree. You see, it's easier to keep track of these numbers, the 42, the this, going on and on and on. This one, okay, let's just leave it out. But it's easier to keep track of these values because here you can easily formulate a sequence of which that sequence, you can see that it will automatically have an R value of 0.95. You see?
Okay.
Yeah. So what this does is it then also needs you to be a bit smart, because if they're going to ask you about the height of the 5th year, then it means you have to work out, as long as you have written it out nicely, you can see that you have to work out the first 4 terms here. You just have to add them up and then add them to 86 for you to get this value. You see that?
Just repeat what you said.
So I was saying they want you to work out the height after the 5th year, right? So what you can easily do is to work out the 4 times that the tree has grown, because look, it's okay. The question in itself, right, is asking us to work out. They said find the height of the tree 5 years after it is planted. So it is planted, 5 years after it is planted. So we have to work out one more actually. So here this is when it is planted, right? So this is like 1, 2, 3, 4 years, 5 years after it is planted. So if you're going to work out the height of the tree 5 years after it has been planted, it means that you have to work out 1, 2, 3, 4, and 5, right? You have to work out these 5 terms here and then add them up and then add them to 86. Do you see?
Okay.
Yes. So that's easier to do because look, you just have to work out the sum of the first 5 terms in this sequence and then you add them to 86. So in your SN formula, you'd have A, Rn minus 1, R minus 1. Our A here is just 42. Our R is just 0.95. Our N, we are working out the first 5 times that it is growing, the first 5 years. And then if you put this in your calculator, you would then have here, what do we get in the calculator?
I'm getting 190,0240125 and rounded up because we can round it up now, right?
Yeah, in this situation, yeah, you can round off to 2 decimal places.
So which is 190,02.
Yeah. So you can say therefore the height is going to be equal to 86, which is the original, right? But then 5 years, it has grown by this much. You see. Then you have 276.02. Do you see?
Okay.
Yeah. So when they speak of something like question 2, right, where they're asking for the maximum height that the tree can grow, because you're dealing with a sequence, if they speak of something like a maximum height, it means that they're talking about a limit, of which when you're dealing with sequences and series and you're talking about where something ends, you should be thinking of sum to infinity. You see? You get it?
Yeah.
Yeah. So in this situation, you want to work out the sum to infinity of this sequence, because sum to infinity gives you an idea of what all of these will add up to if you add them up all the way to infinity. So let's get the sum to infinity of our sequence first. The sum to infinity, a 1 minus r, right? A is 42. Yeah, this one is going to be, I think, I don't know if our calculator can even manage this, because I think this is going to be a huge number. Wait, maybe not. Maybe I'm just exaggerating. Oh, it's just 840. Definitely exaggerated. A huge number. What a wow. It's 840. Anyways, so here it means that the maximum height is going to be equal to 86 plus 840, which is going to be 926. There you go. You see it.